Hello everyone, my name is Vitalii, I'm a JavaScript developer in Binary Studio. Today we will talk about a very interesting topic, patterns, principles and best practices in JavaScript. We will also discuss how to write code better. Let's understand what we are going to talk about. To do this we will use what, how, why method. This method will help us to better understand this topic. The method is self-explanatory. We should ask ourselves three questions. What we want, why we want it, and how we can achieve it. First question, what? What we want to learn from this lecture as software developers. We want to write clear and understandable code that will be easy to maintain during a long period of time. Also, we want to know and use patterns and principles that are commonly used in JavaScript applications. We also want to learn best practices and follow them, and of course we want to be professional developers. Second question, why? Why we should know all of this? Your code is your responsibility. There are common situations when you need to update some logic that was written 6 months ago or a year ago or even more. And if this code is difficult to understand, then you will spend a lot of time on your task and you can break some logic that used to work. Also, you work in a team. If someone in your team writes incomprehensive code, it will be difficult for you to work and maintain the application. Even worse if the bad coder is you. Good code is easy to maintain and extend. An application with bad architecture and non-understandable code will slow down the development process and can lead to unexpected behavior and bugs. Another important reason to write good code is that it is easier to debug it. And last but not least, you are not the owner of your product in most cases. You need to understand that you are selling your code. Would you like to buy a substandard product? I think no. Then why should a customer buy a poor quality code? The third question is how. How can we achieve this? We can watch lectures of professional programmers and read their books and blogs. For example, the lectures of Eddie Osmani, who is the author of several books about JavaScript design patterns, or we can read the blogs of Dan Abramov, author of React. We can also take various courses on the platforms like Coursera or Egghead or any other platform. The next way to get the skill of working with patterns is to see how the open source modules or applications work. But here you need to be careful because you can easily come across a low quality code. Open source code is also written by people and they may make mistakes. And another effective way is code review. A more experienced person can suggest which pattern can be used to simplify your code or which principle you violated. Here is our agenda for today. In this lecture we will discuss solid principles and design patterns in JavaScript. We will also touch on functional programming, its principles and user techniques. And finally, we are going to talk about best practices and JavaScript style guides, what it is and why we need it. SOLID is an abbreviation of the first letters of the principles of object-oriented programming and design, proposed by Robert Martin. These principles are the rules of a good architecture. They are necessary for the development of systems so that they can be developed, extended and maintained for a long period of time. These principles have been developed for object-oriented programming languages. Although JavaScript is a prototype-based language, it makes it possible to implement both object-oriented and functional approaches. This is also important to know because many modern applications are developed using TypeScript and an object-oriented approach. So here is the principles. Single responsibility principle, open-closed principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. The first principle is the single responsibility principle. This principle sounds like this. A class should have only one reason to change. From this we can conclude that the object must do one thing, but this is not entirely correct. An object must have a linked set of behaviors that relate to one specific responsibility. And only a change in this responsibility should lead to a change of class. A very simple example. If you have a fork to eat pasta and a spoon to eat soup, then if you try to improve the fork so that you can eat soup with it, you will get a not usable thing. An object that has multiple responsibilities is problematic because changing one responsibility can indirectly change another. Separation of responsibilities makes the code more resistant to change. But here the question arises. How to determine that a particular set of behavior is a separate responsibility? This is why the division of entities into categories according to responsibilities is used. For example, object role stereotypes. This practice can be found in an approach known as RDD, responsibility-driven design. For example, the coordinator that reacts to events by delegating tasks to others, structure that maintains the relationships between objects, etc. It is not very important how it is done there. You can divide entities into your own categories. The main thing is to divide your objects into certain categories and follow this division while implementing the functionality of the application. Let's look at the example. Let's imagine we need a class to change user settings, but before changing it, we want to make sure that user entered valid credentials. We created class user settings with method change settings. In this method we call another method verify credentials, but by creating verify credentials we violated single responsibility principle. This class have two responsibilities. First, it changes user settings, and second, it verify user credentials. We would better write this code and create two separate classes. First, user O's that will verify credentials, and second, user settings that will call a method of an instance of user O's to verify credentials, and then it will change settings. So each class have only one responsibility. User O's validate credentials and user settings change settings. If you wrote code for backend applications, you probably already followed this principle. Divided code into services, middlewares, controllers, and so on. You should always follow this principle and not create a Swiss Army knife. Just because you can doesn't mean you should. The next principle is the open-closed principle. Software entities should be open for extension but closed for modification. The architecture of the application must allow the change of a certain entity without changing the entire application or existing functionality. For example, we have a mixer, and to cook different dishes we just need to change its attachments and not change a mixer itself. Let's say we have class HTTP requester that can send requests using different adapters, for example node adapter and Ajax adapter. In constructor we pass adapter name, and according to it the request is executed. It works, but if you need to add one more adapter we would need to change this fetch method, and changing this method can break some already existing functionality. It is better to implement the request method in each adapter that will actually send request, and in HTTP requester we just in constructor pass this adapter, and in fetch method we call request method of applied adapter. So we can have infinite amount of adapters, but HTTP requester will not change because of added new adapter. The next principle is the Liskov substitution principle. It states that objects in program should be replaceable with instances of their subtypes without altering the correctness of the program. This principle most often is associated with inheritance, but the essence of the principle lies in the behavior compatibility of objects, which is also relevant for JavaScript as a dynamically typed language. In object-oriented languages, inheritance allows reusage of code in similar classes. This is achieved by encapsulation of logic in base classes and reusing or redefining behavior in child classes. According to this principle, the behavior of descendants should be equivalent to the behavior of the base class. A simple example, we have two entities, one a sportsman, the other one is a sportsman powerlifter. If one is healthy, then the other must also be healthy. Let's go to the example in code. Here we have base class items repository with method delete that performs some delete query, sets number of deleted rows and returns this number. Also we have item service that use this items repository to execute delete query. And in item service we are expecting that method delete will return us number as we use items repository that returns number. We created extended items repository with delete methods that also execute delete query, sets number of deleted rows, but it returns undefined. If we use extended items repository with item service, we will get undefined instead of number in method delete. Extended items repository violates Liskov substitution principle because its methods are not equivalent to methods of base class, and we cannot use it instead of base class. The next principle is the interface segregation principle. It sounds like this. A client should never be forced to implement an interface that it doesn't use, or clients shouldn't be forced to depend on methods they don't use. This means that interfaces with a large number of methods need to be divided into smaller but highly specified, so that clients know only about the methods they use. As a result, when changing the functionality, those classes that don't use it should remain unchanged. For example, we prefer to use two interfaces, one to charge phones, the other to charge laptops. Then to combine these interfaces into one and force to implement charging for laptops to those who don't need it. Let's imagine we are creating a game. We created interface character with methods for shooting, swimming, talking and dancing. Then we create person that implements this interface. Person can shoot, swim, talk and dance, so everything looks great. But implementing troll that can only shoot and dance, we are forced to add methods that troll don't need. So it is better to split interface character into smaller but more specified interfaces. For example, talker, shooter, swimmer and dancer. Person will implement all of these interfaces, but troll will implement only those that need it, shooter and dancer. The last principle is the dependency inversion principle. It consists of two parts. First, high-level modules should not depend on low-level modules. Both should depend on abstractions. Second, abstractions should not depend on details. Details should depend on abstractions. In other words, you need to develop software so that individual modules are autonomous and connect to each other through abstractions. For example, we have an abstraction power socket. We are not interested how it is done internally, which wires are used or how other parts of it are made. Only abstraction is important for us. For example, we have class software project with method create project. In this method, all team members start work. For front-end developer, we call write HTML code. For backend developer, we call write TypeScript code. As you see, all developers are created in constructor. This means that if a new developer is added, we would need to add it in constructor and update method create project to call technical specific method for a new developer. It is better to make class software project independent from specific developers. We can create interface developer with method develop All developers must implement this interface. Front-end developer and back-end developer will have methods develop, and in that method we will call some methods to create project. For front-end developer it is write HTML code, and for back-end developer it is write TypeScript code. And in software project we will have an array of developers, method extend team to add a new developer to the project, and method create project will just iterate an array of developers and call method develop for each developer. Now software project and developers depend on abstraction on interface developer, and that's more flexible than depending on each other. These principles are general and do not depend on the programming language. You should follow them while implementing the object-oriented approach. Let's move to design patterns. And we are starting with a question: what is pattern? We can find such a definition in the Wikipedia. A software design pattern is a general, reusable solution to a commonly occurring problem within a given context in software design. Simply put, it is a solution to a problem that often arises when designing a program architecture. The pattern is not a specific code, but a general concept for solving a problem, and this concept needs to be adjusted to the needs of the application. The pattern can be confused with the algorithm because both are designed to solve common problems. But they are significantly different. If the algorithm is a clear set of actions to achieve a certain result, the pattern is a description of the solution. The implementation of this pattern may differ in different programs. If you take a live example, the algorithm is a recipe with clear steps and sequence of actions. And the pattern is like an engineering drawing, which depicts a solution but not specific steps for its implementation. Why should I know this, you wonder? Moreover, you may not know about the existence of patterns but implement them in your application. But conscious possession of the tool distinguishes a professional developer from an amateur. Thus, the patterns give the developer a number of proven solutions to work with. Secondly, they are neutral and can be applied to any language that supports object-oriented paradigms. Third, they help you understand each other when you explain your decision to other developers. Fourth, they are proven to be working because they are widely used by a large number of developers on various projects. And lastly, they are very flexible and can be used in any domain. Classification of design patterns. The lowest level and simple patterns are idioms. They are not universal because they are applicable only to one programming language. The most versatile are architectural patterns. They are needed to project the entire program. We will consider this type of patterns. Patterns are classified by purpose. So there are three main groups of patterns. The first group, creational patterns. These patterns abstract the process of creating objects. The next type is structural patterns. These patterns can help us to create larger structures from our classes and objects. They show ways to build relationships between objects. The third type is behavioral patterns. They are related to the interaction and the distribution of responsibilities between objects. They show how objects are communicating with each other. There is a set of patterns for each of these categories. We will not consider all of them because it will take a lot of time. We will only look at a few examples from each group. The first pattern we will consider is the singleton pattern, quite a popular creational pattern. It guarantees a single instance of the class and provides global access to the same object. This may come in handy when we need to provide access to a single unique store of data. Here is the implementation of singleton pattern in JavaScript. We want to create logger with a single file stream. For that, we need single instance of the logger. We have self-invoking function that returns object with the method getInstance. This method will create an instance of the logger if it doesn't exist, or return the existing instance. The instance is saved inside self-invoking functions and can be accessed only there, so it cannot be rewritten anywhere in the application. It doesn't matter how many times we call getInstance, we will receive the same instance of the object every time, so we have only one instance of logger. Another creational pattern is builder. This pattern allows you to gradually create objects that usually require a large number of parameters. Such classes usually have giant constructors that are difficult to work with. To simplify the work, we can create a separate class, builder, which would manage all these parameters and return the instance of the object we are building. When creating a backend application using Nest.js, you can document your API using OpenAPI schema. And for creating this schema object, you can use document builder. There are many methods to add properties to the object, for example, set title, set license, set text, set version, and a bunch of others. You can easily use part of them, only those you need, and ignore others. Using a builder is much easier than creating such an object yourself. The next pattern is a facade pattern. It is a structural pattern designed to combine groups and subsystems under a single unified interface, giving them a single access point. Well, let's say your code works with a large number of objects and libraries. You have to initialize all objects by yourself, configure dependencies, and all this stuff. That takes time and makes your code less readable and understandable. You can create a facade instead. It will be an interface to work with these complex systems through a single entry point. An example from life. You want to order a phone, bananas, and a book. Instead of calling to the electronics products and bookstores and making orders there, you just go to an internet shop, choose everything you need, enter the address once, and everything is delivered to you. Let's imagine we need to create a system that will find some media by its ID. We have music, movies, TV shows, and books. All this data have different interfaces to work with, and to complete the task we would need to check the type of media, then find the needed items. Also, we would need to handle errors, etc. This will look messy. To make it more organized, we can use a facade pattern. In the constructor, it will take the media type. It will also have a method get that returns media by its ID. For each media type, we have an internal method that will return needed media. And we also have a method for handling errors and calling these internal methods. The usage of this facade is very easy and declarative. We create an instance of the facade with the needed type of media and just call the get method. That's all. Looks very easy to work with. Let's move on to the next pattern. It is the observer pattern that refers to behavioral patterns. This pattern implements a subscription mechanism that allows some objects to monitor and respond to events in other objects. Well, for example, we want to buy a laptop, but the store doesn't have it now. We leave our phone number, and when the store has the laptop, we get a call. Now we can go to pick it up. The observer pattern is very simple. There are only publisher and subscriber objects. The publisher generates an event on some action and informs all subscribers that something has happened. Here we have the smallest example of the observer pattern. The class eventObserver has just three methods: subscribe, unsubscribe, and broadcast. Subscribe method adds a new subscriber. In this case, subscriber is just a plain function. The unsubscribe method removes the subscriber, and broadcast method notifies all subscribers by calling these functions with the provided data. You can extend this implementation by adding event names and allowing subscriptions to specific events. The observer pattern is widely used. For example, it is used in the Redux library. We have a dispatch that requests state changes. Then the state is changed in the reducer function, and when data is changed, all subscribers are notified about it, and it can get a new state. There are cases when it makes no sense to use patterns. Often patterns are already implemented in a programming language or in a framework. For example, the proxy pattern has already been implemented in ECMAScript 2015. Also, there is no sense to use patterns if you are creating a simple project or proof of concept. Another reason why you shouldn't use these patterns is when your team uses their own patterns on projects. Patterns are optional rules. Everyone can choose whether to use them or not by themselves. The team can just stick to other patterns and your code can be inappropriate. You should also think about whether the use of the pattern is justified in this particular case or not. You can ask the question to yourself, will I gain something if I use this pattern? Well, in conclusion, I would like to summarize. As you can see, patterns allow us to use ready-made model to meet our needs instead of creating something new. Patterns have already been tested a lot of times, which means that the probability of sudden bugs is low. If you imagine that all members of the team are aware of these patterns, the code review can be much easier. The third section of our lecture is functional programming in JavaScript. In the last few years, functional programming has been gaining momentum and becoming more and more popular. Functional programming languages are being used more and more, and various functional concepts are being developed. The era of functional programming is coming. Words such as lambda, monad, and carrying are being used more and more often. Today we will talk about this approach not because it is very popular, but because it will help us make our code cleaner and more readable. Let's first understand what it is. Functional programming is a paradigm that considers a program as a calculation of mathematical functions and avoids states and mutability of data. In other words, it is a style of writing program in which we mainly use and combine functions. We will analyze this in detail step by step. Why should we use functional programming and what are the advantages of this approach? The first is the cleanliness of the code. The code written in a functional style doesn't depend on external factors, states, etc. And therefore it is easier to understand it. The second is modularity. We can combine several functions in a module and distribute the code. The third is reusability. We can use some features anywhere and avoid duplicated code. The fourth is to reduce the connectivity of the code. The code is decomposed into different independent structural parts, which allows you to change some parts without affecting other parts of the application. Well, the last thing is that functional approach is based on a mathematical model, i.e. most approaches are proven mathematically. This may raise the question, how about OOP? Using functional programming or object-oriented programming depends on your preferences or the specifics of the project or the qualifications of you and your team. Moreover, these approaches can be combined. Let's look at some parts of functional programming in JavaScript more detailed. And we are going to start with the functions. Well, I would like to start with self-invoking functions or immediately invoked function expressions. It is an anonymous function that calls itself. It is used to encapsulate some logic or some data inside. We saw it in the implementation example of the singleton pattern. Higher order functions. These functions either return functions or take other functions as an argument and call them inside. This is one of the key features of functional programming. Let's look at this example. We need to write a function that will filter the list of people over age of 18. We can cycle through each element and see if the age is higher or equal 18. But if we need to choose another group of people, we will have to modify this cycle and add new conditions and so on. The whole power of Hof is that we can write more versatile functions. For example, we can use the filter method and pass there an arrow function which will be called on each element. And this function will check whether this element satisfies the condition. We can do this even more explicitly. We can save a function that checks the age of the person into a separate variable and simply pass it to the filter function. The next concept is pure functions. This is another feature that underlies functional programming. What are pure functions? These are functions that return the same result with the same input data. This means that the function should not depend on any variables outside it or any global state. Also, these functions should not mutate the input parameters. Let's take the add function. If we pass 2 and 3 to this function, wherever we call it, it will return the same result. If you look at the add function below, it depends on the execution context and also changes the variable outside of its execution, i.e. such a function is not pure. You also need to be very careful to keep arguments immutable. For example, the slice method does not change the array, but the splice method changes it. Since we are considering pure functions, it is worth considering some important concepts in functional programming that are related to this. One such concept is immutability. It assumes that once variable created, the data or structure that contains them cannot be changed. For example, string in JavaScript is immutable. It cannot be changed. When we change a value, we always get a new string. The original string remains the same. Immutability guarantees us that the data will not change in any way, so we control the whole flow. Most problems arise when the data is changed in some function where we don't expect it. Then we may have an unpredictable result and it will be difficult to find the problem. Functions that mutate data can create unexpected side effects. Side effects are any actions of the program that can change the execution environment. It can be the execution of database queries, a change of some global information, work with input-output, events, file system, etc. That is, working with data that is used somewhere outside the function. When performing such functions twice with the same arguments, the result may be different. Such functions are called non-deterministic, i.e. functions with side effects. Another concept worth understanding is the shared state. This is data to which the program has access. According to the paradigm of functional programming, we avoid cases when we need to change the state. But in case it is provided by a program or algorithm, we don't change it but overwrite, i.e. create a copy and make changes to the copy. In addition, if we want to write pure functions, they should not change the state. A vivid example of these three paradigms is working with data in React Redux. Everything is quite clear here. For example, we have a common state of the program that we can change with the help of so-called actions. They are always pure functions, and actions are passed to the reducer. The reducer is a function with a set of methods that updates the data. And depending on what type of action came, some data is changed. To make it clearer, let's see the example. We have three actions for working with the user entity: add user, remove user, and rename user. These actions are pure functions. They return us objects with the type of method and the data. They are passed to the reducer, where we operate with the state. If we need to add the user, we push it to the array of the users. If we need to remove user, we remove it from the state, and so on. In any case, we don't directly change the state. We make a copy and just overwrite. In JavaScript, we can also create anonymous functions. I think the name speaks for itself. They don't have a name. It often happens that the function is needed only once. In this case, it may not make sense to create a separate function. It is best to create an anonymous functions where necessary. Anonymous functions embody lambda calculations. They are often called lambda functions or lambda expressions. Lambda calculations were invented long before computers. It was just a mathematical concept of functions. Today, lambda calculations is the basis of all functional programming languages. Functional programming techniques in JavaScript. One of the most popular techniques is chain of methods. This is a set of methods that are sequentially called. This technique is useful when we need to call several methods to the same object one by one, and it doesn't make sense to store the intermediate result in a separate variable. For example, we have an array of numbers and we need to perform 3 actions. Several variables in which we store the intermediate result are redundant. We can just call these methods in chain. In addition to built-in methods, you can add your own through a prototype of array. The next technique is recursion. This is probably one of the most well-known programming techniques. I think most of you are already familiar with it. For those who don't know, recursion is a function that calls itself. One of the most popular examples of using this function is calculation of factorial of the number. Recursion is used when it is necessary to perform the same action cyclically. For example, find or change some vertex in a graph or a tree. Using recursion, it is important not to forget to set the exit condition, else the function will call itself infinite number of times and will lead to a Stack Overflow error. Partial application is the process of fixing a number of arguments to a function, producing another function of smaller arity. In the result function, some arguments have already been replaced by values. For example, we have a function that allows us to calculate the power of a number. We pass to it the exponent and the basis. For example, we would like to have functions that power a number to a square or a cube. To do this, you can create local variables square and cube. And accordingly, we pass 2 and 3 as exponents. Here we do it manually. It would be desirable to organize it somehow through a wrapper. We can create a partial apply function, which will use bind to create a new function with partially passed arguments. That is, we can do the same thing using the partial apply function. The main thing here is to understand the principle. We create a new function with a smaller number of arguments based on a different function. The next technique is carrying. Carrying is the technique of transforming function with multiple arguments into a sequence of functions, each with a single argument. This may sound a bit confusing, but let's look at an example. Let's say we have a triple sum function that adds 3 arguments. If we use it carrying, then we would rewrite it as follows. This function would return another function to which the second argument is passed. It will return the third function with the third argument, and as a result, when we call the third function, we will get the result. Calling the original function will look something like this. If you use carrying, then the function returns us not the result, but another function. So we need to save it, then save another function. As a result, we will get the value. It may not look good or comfortable at first glance, but it is used very often when you need to partially transfer parameters and call a function elsewhere. Also, of course, there is an easier way to call a carried function using just a chain one by one to pass arguments. Beginners in functional programming may confuse the concepts of carrying and partial application, or consider them the same. So you need to be careful. Carrying always creates same functions with one argument. Partial application, in turn, can create functions with a different number of arguments. And new functions differ from the first because they have fewer arguments. The last technique we will look at is the composition of functions. This function is built of several functions, so that the result of the first function is an argument of the second. For example, a MapReduce implementation with the function composition technique might look something like this. It seems that everything here is quite simple and clear. The result of one function is transferred to another function, there is a new result, and so on. At the end, returns the result of the last called function. In general, this will be enough for us to start. What we have considered are basic generalized concepts in functional programming. In addition, there are a lot of different concepts and approaches, which are not very important for us, because the task of this lecture is to acquaint you with approaches to writing clean code. You may think that to comfortably use functional programming you need to write many different wrappers, but this is not the case. Everything you need has been written for us. You may have heard of some of these libraries or even used them on your projects. For example, the very popular _JS library allows you to conveniently manipulate arrays or objects. Ladash is a very similar library to the underscore, but has additional methods for working with functions. Lambda has similar functionality as the first two, but it is based on a composition of functions. It is better suited for the use of a purely functional style because it strictly adheres to its concepts. Lazy.js supports similar functionality as the previous ones, but the main thing is to work with so-called lazy evaluation strategy and lazy loading. Bacon.js and the Rix.js libraries for working with reactive programming. That is, many tools have already been invented and you are free to use them in your projects. Also use built-in array methods. This is a fairly large number of methods with which it is convenient to operate, process data cyclically, change, add, delete items. But you need to be careful because some methods mutate arrays, such as push mutates the original array by adding a new element. Let's move on to the last part of our lecture, JavaScript best practices. Here we will talk about how to organize the code, how to format it, and so on. These rules have little effect on the execution of the program or on its performance. But it will make the code neater and more understandable for other developers. The first thing we are going to talk about is clean code. When we talk about clean code, we mean a set of rules and practices that improve the code and make it cleaner and more readable for developers. It's joked that code quality is measured by the number of WTFs said during a code review. A set of ideas, rules and practices of clean code was taken from a book by Robert Martin called Clean Code. There is a great guide with examples on the GitHub. We will consider a slightly filtered version because some ideas we have already passed and some ideas are a little outdated. We are going to talk about 7 topics, so let's start with variables. First, for variables you need to use meaningful names that are easy to pronounce. The name of your variable should say what is stored there, and also it is much easier to say, hey, there is an issue with current date instead of pronouncing y, ms, mdr, str. I don't know how to pronounce this thing. Also use the same vocabulary for your variables and the names of functions. For example, for functions to work with user entity, it is better to use names such as get user, find user, change user, etc. instead of get user info, get client data, get customer record. It is confusing to use the function get client when there is no entity client in your application. Use searchable names. For some magic numbers, constants, create variables with a meaningful name. It will be easier to understand the code for someone who read it. Also, use explanatory variables. The variable should explain why it is created and what is stored there. Sometimes it is better to store intermediate result to make it more obvious. For example, here we have an address and some regular expressions that parse it. The result of regex is immediately passed to the function, and we don't actually know what is parsed. It is better to save the result into separate variables such as city and zip code, and then pass them to the function. Now we know that regular expression returns us city and zip code. Avoid mental mapping. Don't make your code implicit and incomprehensive. This means that you shouldn't use abbreviations. It is better to use full names because it is easier to lose the meaning of L, for example, in our case. It is better to use obvious name location. Now you anywhere in your function knows that it is location stored there. Don't add additional context. If your class object name tells you something, don't repeat it in your variables. For example, there is no sense to name variables car color, car model, car make, because it is evident that color and model are properties of the car object. And also use default arguments instead of short-circuiting or conditionals. You don't need to add an additional line of code for checking whether an argument is not undefined. Just use default arguments, they are easy and obvious. But you need to be careful because default argument is applied only when undefined is passed. And let's move to functions. Use a small number of arguments because it makes testing your function easier. 1 or 2 arguments is the ideal case, and 3 should be avoided if possible. In case you need more arguments, you can use an object. To make it obvious what properties the function expects, you can use the ES 2015 destructuring syntax. When someone looks at the function signature, it's immediately clear what properties are being used there. Also, make it obvious what your function is doing. For example, it is hard to understand what the function addToDate is doing. We don't know what is changed, how the date is changed, so much easier to understand that what the function addMonthToDate is doing. Try not to duplicate your code. Remove duplicated code by creating separate functions that do the shared work. Because if there are any changes in the business logic, then you will not have to rewrite the duplicated code throughout your application. You will change it only in one place. For cases when you have an argument object and you need to set its default properties, better use object assign with the default object instead of using conditional operations. If you have like 10 different properties, you would need to add 10 checks like this. When using object assign, it is much more obvious which default values are used, and it just looks more cleaner. Don't use flags in your function. A flag means that your function does two things. It is better to split it into two separate functions. For example, this function we can split into create file function and create temp file function. Avoid conditionals. If it is possible, it is better to split the function into separate functions. In this case, for example, we have get cruising altitude that calculates the altitude by type of airplane. We can create child classes with their own get cruising altitude, and they will return the value without all these checks and all this large switch case. Don't over-optimize. Optimization is important, but a lot of small optimizations like this are already done in modern browsers or minifiers. Don't hurt the readability of your code with optimizations. Also remove dead code. If the code is not used anymore, just delete it. You don't need to keep it in your application. If you would need it sometime, you always can find it using Git history and just copy it from there. That's all about functions. Let's move to classes. Use the ES 2015 syntax for creating classes. Better use synthetic sugar introduced in ES 2015 with keywords class, constructor, extends, instead of using prototype. How the classes were created before ES 2015. We created a function that embodies the constructor. Then using the prototype we added methods. We also duplicated prototype for child classes to implement inheritance. It looks messy and it's hard to understand what is going on in this code. Class syntax is much more simpler. Anyway, under the hood they are the same. Next topic is concurrency. First of all, forget about callbacks. Use promises. Don't use callbacks because it's hard to maintain them, and callbacks inside callbacks, they are hard to debug and hard to understand how the data is changed there. Such mess is called callback hell. Better use promises with their then and catch methods, or even better than promises, use async await. They are very simple and declarative. Use it and forget about callbacks. Let's move on to error handling. First of all, don't ignore errors. It's not enough to just write an error to console. Users don't know about the error and developers don't know about it. And even if developers know that something's working incorrectly, they cannot debug it because they have no stack trace. Notify user about the error and send the error to some log system. Also, don't ignore promise rejections, the same as above, but about promises. And also don't forget to write catch statement if you use promises. Next our topic is formatting. Use consistent style of the names of your variables, classes and functions. For example, use Pascal case for classes, camel case for functions, uppercase for constants. It doesn't matter what styling you are using, just keep it throughout the application. Inconsistent styling greatly impairs the readability of your code. If a function calls another, keep those functions vertically close in the source file. Ideally, keep the caller right above the callee. We tend to read the code from top to bottom like a newspaper. Because of this, make your code read that way. For example, we have a function parse review. The next function get peer reviews. It's right below. The next function is lookup peers. It's right below, and it is easy to read such file. And the last our topic is comments. Don't comment every line of your code. There is no need to do so. Code should be self-explanatory. Better comment only some complex parts of business logic or some parts that can be incomprehensive. Also, don't leave commented code, the same as with dead code. There is no need to keep it in your application, just delete it. If you need it, you can always find it in Git history. Also, don't use journal comments. There is no need in such when you're using version control system. Just use proper messages in your commits and you will get the history with command git log. And the last, avoid positional markers. They usually just the noise. If your variables and functions are named properly, you don't need any positional markers. That's all about clean code. Let's back to the presentation. JavaScript style guides. The style guide is a guide with rules that describe how code should be written, organized, and formatted. When you read such manuals, you can get an idea of how the code is written in some companies or teams. The question arises, why do we need style guides? For one simple reason, everyone writes code differently. And when there are 4 people in a team, it is still possible to reach an agreement. But when 100 developers work on the code, it becomes simply impossible. Style guides are designed so that new developers can quickly adapt and write code that will be understandable to team members. There are several popular style guides, usually the style guides of well-known large companies or style guides offered by developers of libraries or frameworks. For example, here is how Airbnb style guide looks. It looks pretty similar to our clean code. For example, we can check how they declare functions and that they recommend to wrap if expressions in brackets and a lot of stuff. Also Google style guide, very similar to the previous one. For example, classes, constructors, fields, all is described why it should be used in that way and so on. You can use one of the public style guides or make your own. The main thing is to always follow it. In addition, some tools allow you to track or format code. They may indicate some syntax errors, invalid code, formatting violations, etc. Most of these tools are supported by many popular code editors or IDEs. The most popular tools are JSHint, JSLint, ESLint, and various plugins for IDEs such as spell checker and other tools. Well, the last thing I would like to say something about is code review. It's like the exam of your code. This is a great opportunity to see and analyze your mistakes, especially when your code is viewed by an experienced colleagues. It's also a great opportunity to look at someone else's code and possibly adopt some practices and approaches. What should be said in conclusion? Learn different approaches in programming. Try to practice the use of patterns and in any case don't create a wheel. Try to write clean and accurate code. Every time you learn something new, try to use it in practice. After a while you will start to like this or those approaches and in general you will start to like your code. Remember that the machine will understand any code, but only a good code can understand a developer. This feature distinguishes a professional, so be a professional. I hope this lecture has taught you something and it will motivate you to write good code. Well, in conclusion, 3 small principles of clean code. Yarny, or you aren't gonna need it. Don't leave in the code functionality that you don't use. Leave only the logic you need at the moment. The second principle is keys. Keep it simple, stupid. Make your code as simple as possible. Don't try to come up with any complex structures. Make the code simple. And the third is dry. Don't repeat yourself. Don't duplicate the code. Try to write pure universal code as much as possible, avoiding duplication. In the end, let's take a look at some resources that will allow you to learn more. Adaptive code is mostly about solid books, JavaScript patterns and JavaScript design patterns, and a very cool resource, Refactoring Guru. This all about patterns in details, when, how, and why to use them. Patterns dev, it's most about the principles and good practices in the development of React applications, as well as various ways to optimize websites. Functional Programming in JavaScript is a great book on functional programming. Also, the book Clean Code, on which the considerable part of today's rules is based. There is also a wonderful book, Code Complete, that is very similar to Clean Code. So that's all. Thank you for your attention.